This conference will now be recorded.
Yes, guys, let's start the session and the others might join in between. That's fine. We'll start our session now. I'm sharing my screen. Let me know when you can see it.
We can say it, yes.
Okay. So we were in this topic of creating our planning model. Yesterday we created a planning model and then we loaded some data into it, master data and key figures, and then we did. We have analyzed how we can play with the data and how we can view the data at different levels and the aggregation and disaggregation and etc. and how they work. So as we have discussed, so we should follow this cycle. Just a small recap, guys, on the yesterday's session. So whenever we deal with the planning model and mm, if you make any change or be it adding a new key figure or be it adding a new master data element or anything, so first you have to do the define part and then do the activation. Activation might throw some errors, fix those errors, get them activated successfully, and then you import the data into that model. If you made a change to the master data and then load the data into into the master data, and you can reflect the changes in the key figure data also, and then finally yes, you can very well use it. So kind of this is the planning model and all the different elements that constitute our planning model. So the scenario that we have seen is that we wanted to do a capacity planning scenario where there would be multiple maintenance jobs that we do inside a plant on a particular resource. So we created a master data called maintenance job, and prior to that we created the attributes that are required. So these are the attributes that we had thought of: maintenance job ID, maintenance type, and technician name. So we followed this procedure. So first we created all those attributes, and then we made one master data, and then we also made one simple master data, and then one compound master data. um, Simple is just related to a segment of your business, data, I would say. So resource is one master data, and location is one master data. Maintenance job is one master data, whereas a compound master data will constitute two or more master datas, and then and then also it will take other attributes which makes more sense if we have the other dimensions from other master data. So we created them, we activated them, then we went into our planning area called test config. We extended them to our planning area, And as I said, the master data types that we created, and once we activate them, that can be reused across the planning areas. So, and then also the attributes. So, they in a way they stay out of the planning area purview. But once they are made, and you can very well assign it to them a planning area. We have extended them, and then our intention was to create a key figure. Yesterday we created something called maintenance costs, and that key figure signifies that how much of the cost that I have spent to perform every maintenance activity. So that key figure we have made at a particular level. Why? Because that key figure data will make more sense if I make it at that level, or the requirement is to view the key figure data at that level. And the level is that what is a location, and then what is a resource, and then what kind of a maintenance job that you have worked in. Location is plant one, resource is robotic assembler, maintenance job is oil cleaning and dry vacuum services, and repairs and servicing, etc. And every unique combination will have a particular cost. So so before creating a key figure, we have to create a planning level. So the planning level takes the master data types and then the time profile in it. Time profile brings the time dimension to it. Master data brings the planning level dimensions to it. And then um so just like, I mean, another thing here, guys, I mean, you can create 10 attributes and then assign it to one master data md1. You can further extend it to a planning area md1, but here you can pick only 8. The rest of attributes are not required for your planning area purposes. And then you will there is a checkbox, I mean, if you have remembered there, so you can go and pick the 8 ones that you want. And when you're further extending this master data type to a planning level, you can further make a very a detailed selection, and you can just make only 4. So the master data will have 8 attributes, but when it is going to planning level 1, PL1, you'll select only 4. And then you create a planning level 2. There you can select all 8, but you cannot select all 10. Why? Because the planning area does not understand the attribute 9 and 10, because they were not extended to this planning area. Only 8 are extended. Another point here. In the planning level 1, you added master data 1 and you assigned 4 attributes. And like, for example, maintenance job is a master data. The root is a maintenance job ID. But whereas in planning level 1, you can make maintenance job type as a root, and then you can create a planning level 1. In planning level 2, you use maintenance job technician. You make that attribute as a root and then build your planning level. Why? I mean, the IBP gives a facility that you can pick any level that you want to do planning on. So some key figures, maybe you just want to do at the technician level. So you want to see the technician named John, and where all he is involved across your supply chain network, and how many hours he has spent, etc., etc. So you want to view the data at the at the technician level. So, and you want the data to be viewed and reported at the technician level, and there are some calculations that you want to do at technician level. So you can very well create a new planning level, which the root is at the you know technician level. The moment you say it is a root, that the data has to be present at that root level to make the planning. I mean, so if you don't have, for example, here you made technician as a root, and in the master data, if you don't have, for any record, if you don't have a technician name, that entire planning combination will get invalid, and then the key figure data will not get loaded, because the planning level cannot be made because the root is not having any value. Okay, so So we created the key figure, and then we saved it, and then we activated it, and then we have started analyzing it at different levels. So today let's do. So today first we'll start with so what topics I have for today. So today what we'll do is the first topic for today would be attributes as key figure. With this topic, you can actually pick an attribute in the master data, and then you can make it as a key figure. So an attribute is a static value. Maintenance job ID, oil, oiling and dry vacuum services. It's a static value. So even if you take an integer that if you say the priority, the maintenance job priority, 1, 2, 3, 4, 5, you give 5 priority, one being the highest priority. So if you say for a particular combination that in this plant, this maintenance job activity, the priority is 1, the priority is 2, but that 1 is just a static value. But if you mark it as a key figure, then this attribute will have all the dimensions, all the functionalities of a key figure. What functionalities we have in the key figure? There are like, you can see here, there are these other options that you can actually make it as a if you mark an element as a key figure. So you will have a aggregation method, you have a disaggregation method, you have a base planning level. mm, uh, uh, you can write a calculation for it. There is a planning notes that you can leave a planning note, you can enable fixing, and etc. So you can do a whole lot. So um that's and then this attribute might come as a as an integration element from S4 system. Like a classic example would be the unit price. So a unit price, um, for a location product or for a customer product combination, selling price, MRP price, I mean to say. So this Samsung S12 product, if I sell it to Amazon, it is a $500. If I sell it to eBay, it is $400. So that 500, it's a static value, but I want that value to be there available across the horizon, so that I can do some calculations with that unit price in the quarter one of 2020. If my forecast is customer forecast is 10,000 quantities, and I have this unit price with me, I can do the multiplication and I can come up with some revenue forecasts. 10,000 quantities into $500 gives me some big value. So that's kind of a, use if you actually make something as a key figure. And here you don't have to go and maintain the $500 across the horizon. You don't have to go to every week and say that $500, $500, $500, and save it. You don't have to do that. You don't have to load that. It's a master data element, and it comes as a static value. But I'll take that static value and I'll propagate that static value across the horizon. We'll see that. The second topic would be, and this attributes also key figure will also cover, you know, that is how to deal with new requirements, and it's how to insert them into the active planning area. Okay, so next topic would be, so under the key figure calculation, so we'll write a lot of um, key figure calculations now. So we'll see the planning nodes, and we'll also see the fixing, and then also cover capacity planning scenario. These are the things that we're going to cover it today, guys. So let's come back to this thing. So now I'll tell the requirement. how as a business I want to do my capacity planning, and then we'll do the reverse engineering, and then to meet that requirement, what all things that we have to configure, and then how we need to make changes, etc., etc. Okay, so I think yesterday we have I'm just verifying the master data that we have created yesterday, especially that compound master data. And okay, this is our compound master data, and it has the name is location resource maintenance, and then there's okay, there's something called as a job priority. Okay, guys. So this is the for now we'll focus on this. So the requirement is that I have the master data is available. The master data are created, and the master data will tell that what resources are extended to what plans, and what kind of a maintenance activities that it requires. Robotic assemblers will require some kind of a jobs. Manual assembler will require some kind of a jobs, and then we have all those valid combinations available. This is another set of the master data key figures. So see, I mean, key figures, always remember, I mean, I'm putting everything in tabular format with rows and columns, don't get confused. When we say key figure, there would be a time dimension to it. I mean, you guys all know it, so you can see that week 1, week 2, week 3 across the horizon. So um, there is another standard key figure called as a key figure that tells that how much of capacity is available inside a location for a particular resource. There is a key figure, let's just say that there is a key figure called standard capacity. It is 168 hours, 168 hours, 168. Okay, and then this is manual assembler. Okay, my resources are available 24 by 7, 7 days a week, and it can run for 168 hours, and it can do the production for the 168 hours. But there are some maintenance activities that would go on. So now the maintenance planner, he will come and he wants to tell it to the system that in a particular week inside a plant for a particular resource there is this kind of maintenance activity is going on. So he wants to flag that particular time period. So he will come and he will say that you know um, this combination robotic assembler week 2 it is 1. That means in week 2 this job is going to happen inside this location on this resource. That's a key figure, so we have to create this key figure. And of course we have to create all key figures, but yeah, so this is what happens. So he'll just say 1. Now what system has to do? Now system has to do some calculation, and system has to say system has to display the planned capacity consumption by maintenance job. Okay, so now system has to say that this job requires uh, 68 hours. So uh, this requires 68 hours, and then again same here, planned capacity consumption. So here also if it is 1 it is 68 hours. No, let's say oiling is like 50 hours, and if I say 1 also here, then system has to say that 50 is the planned consumption. Okay, from where these 50 and 68 are coming in? Second requirement, they will say, the planners will say that okay, these are the static values, and as a standard the chemical cleaning activity inside this plant 1, it just takes 68 hours, and that's the planned one, and it is available, let's say it is available in the plant maintenance module of S4 system or ERP. The data is there, and then the client will say that okay, please run an interface and then just bring those values, because they'll remain as the same across the horizon. So now for that, let's create a master data and attribute inside the compound master data called as a location resource maintenance. So now here I'll keep the capacity consumed something. So plant 1 robotic assembler chemical cleaning, it takes 68 hours. Oiling takes 50 hours. So I'm just maintaining a static value, a decimal value for this attribute called capacity consumed. So now this is our new attribute. Okay, now I'll introduce this new attribute, and then we'll see how what changes we have to do in this entire architecture, and where all this new attribute, that is a capacity consumed, would fit in, and across the thing. Okay, so now what happens? So user will just do only one thing. User will come and say that in which time period I'm going to perform this maintenance activity. I'll just say 1, and that's it. So system has to read the capacity consumed from its master data. So now let's come back to um, our actual the capacity related key figures at a location and resource level. Okay, so here when we deal with the capacities, we will deal at a location resource level, because we'll not get into the maintenance thing, because the supply planners are really not concerned about the what maintenance activities are happening. Let's say the maintenance planner has to take care of it. So now the standard capacity is 168. Now I have to come up with something called as a planned capacity consumed. I mean, the same key figure, this key figure also has to be displayed at the weak resource, weak resource and location level. So week one, okay, there is something happening. It is 50. Week two, we're going to spend 68 hours and 50 hours, and how much is that? It's a 118, and this is 0. So now there's a final key figure called as a final available capacity. So this is just a subtraction between the standard capacity and what is a planned consumption. So 168 minus 50, that would be 118 here, and then this would be 50 here, and then here we have the 168. So now these are the final capacity figures which we have to load it into the supply planning key figures, so that the supply planning run will respect these values. Okay. So we'll stop here, um, and then also there is another thing. Let's say there is another key figure called as a actual capacity consumed. Okay, so this would come later on, like let's say once the maintenance activity is done, and we'll actually see how much of the time that it has actually taken. So here it might say that actual capacity, it took 60 hours, and in week two it took 128 hours. So now you can see that there is a variance that is happening between the plan versus actual. So IBP, as per the data that we have, we thought that it is taking 50 hours. The plant capacity will get consumed by various maintenance activities, but in actual 60 hours is being consumed, and then there is this difference, so that if the difference is like kind of a consistent across the time horizon, that you can see there's a 10 hours lag, a 10 hours gap is there, so between the plan versus actual. So the actuals are always greater than 10 hours extra. So we can find a root cause analysis, and why this is happening consistently, why we are spending an extra 10 hours when our maintenance activity is going on, blah blah blah. Maybe update the master data records properly, or identify the reason and identify the bottleneck why there is this variance across the time. So now, like, we'll configure this as discussed. First, I'll start with attribute as key figure. So I'll make this attribute as a key figure. Okay, so that this 68 hours will be available across the time horizon, so that I can use this calculation. If I flag it with 1, system reads this value and populates it in this key figure. Okay guys, and then also I'll while configuring the key figures, I'll also touch base on the planning notes and also on the key figure fixing. Let's come here. So I'm inside this master data. Now I want to include um, this attribute now, capacity consumed. So I opened this master data, went into the edit mode. So this is a general information. These are the master data that are assigned, and then these are the attributes that are further assigned. So now I'm clicking on new. The name is now the data type will be decimal. The length would be grayed out because decimals will not have any length. By default, it will take 18 numerics and then 6 decimals. Clicking on save. And one more thing, guys, for the attribute as key figure, this attribute always has to be a decimal. obviously, right? So we key figure means we'll see the decimal values, not the varchars or the timestamps or the integers. So if you make an attribute as a decimal thing, then only we can mark it as an attribute as key figure. So I added this, it not making any changes. I'm not saying that this is key. Obviously this is not key, and it's not a kind of a required one. And then the personal data, it's not a personal data, and etc. So I'm saving it. So there is something called as attribute check here. That means when you are loading data for these 5 attributes, so you can check for a value of any attribute. That means sometimes, let's say, where is this priorities are coming in, right? So you want to keep a attribute check, and you say that I will take only 3 priorities: high, medium, low. Anything else I will not take. That means that data load will be failed. So in that scenarios, you can actually use this functionality called attribute checks, and you can say that please check on this maintenance job priority. Then system would see the valid combinations of that attribute, and if they are valid, then only system allow them to uh, to, to be uploaded successfully. So first I created an attribute, I marked it into it. Now I'm coming back here. So this is our planning area, and it's in active status. So in this planning area section only, we'll specify that if an attribute has to be marked as a key figure, so then that attribute will become, a key figure. So this drop down, we know it first. It will by default, it will show all the selected attributes. You can go for available attributes and check for the attribute that you are looking for, and then assign it. The third option is attribute as key figures. Selected it. So now system would list all the decimal attributes that are there. So I think ours is not being visible. So I'll search for zmain, and okay, it is not there. First, let me make it as a first. I think first we have to add it, then it will appear as attribute as key figure. So available zmain. Okay, this is coming in here. Z maintenance capacity consumed. So this is our thing, right? So capacity required by the job. So here you see this column called as a key figure, and there's a checkbox here. If you checkbox this, then this attribute will become a key figure. I'm doing it. Now the moment I say it's a key figure, then obviously the prime the basic functionality of a key figure, I mean, what makes a key figure is it's the base planning level, the level at which this key figure is been configured. Obviously, if you're saying that this attribute is a key figure, then it will ask that what is the level, at which I have to create this thing. So you can choose from the existing planning levels, or you can create a new planning level. So I'll choose the planning level that we have already created. Now it's a week, location, resource, m job, right? So we want to have at this planning level, right? We want to have a week dimension, location, resource, and maintenance job. I'm clicking on OK, and then system in the backend creates another key figure with the name called Z maintenance capacity consumed. Now the key things here. One is from and to. So from period is a current period. From what period? So if I say 0, that means it takes from the current period. And the 2 means just give some time, like 50. That means for the next 50 periods. What does it mean? Any value, an absolute value that is there in this key, in this attribute, capacity required by the job. If it is 50 hours there, system copies 50 value across from the current period to the next 50 periods. So that is what it is. Saving it. This is key. So from and to is kind of a key, and then at till what horizon we want to make these values available. Okay, now I'm going to the key figures. Now let's create some key figures as per this requirement. Now first we have to fix, I mean we have to do some tweaks into this attribute as key figure, because it will be just if we don't this if we don't do this, then uh, it will fail. Okay, so you see this name is coming in like this, and it is saying that this is base planning level is this, and then edit mode is not editable because it is coming from an attribute value. Now give a name to it. What is it? Capacity required by the job. Okay, so now I need to remember the request level calculation is a mandatory for a key figure. And yesterday we had talked about it, right? What is a request level calculation? Because once the data is available at the base planning level, every location, every resource, every maintenance job, every week, then you can request it at any level that you want. You can request it at a yearly level, or you can request only at a location level. Then system has to do an aggregate and then give the value. How the aggregation has to happen? Sum, just write sum, and then open braces, and every key figure always has to be in the double quotes. It will list all the existing key figures that are there. Pick your key figure, start writing Z, so that system will give you the available key figures. So this is the one that you are interested in. Z, maintenance capacity consumed at the rate week log resource m job. Close this. This is a button that we need to press. That means you are validating the calculation. If the calculation is wrong, then it will throw an error. We have to fix the error and then revalidate. If it is successful, then system would transform this this sentence into IBP understandable logic. So now system will say, when you're validating, system reads the input key figures. You see the name, this pop-up is the input key figures. What does it mean, input key figures? That means in the calculation that you have written, that what key figures we have involved, I mean what key figures we have included in. So I have included only one, that is a Z maintenance capacity consumed, and it is an input and it's a stored value. Clicking on OK, now you can see that it became three colors. First is black color, black in bold. That means it's a kind of a mathematical function, sum, if, etc. And then the technical name would be in blue color, and then the actual planning level would be in green color. The request is in green, the planning level is in green here. Okay, so just save it. Now let's create this first this key figure, job start period. Okay, so this is a major entry by the planner. uh, maintenance job start period, and this is also at a week log resource m job, right? Obviously, because we need all the level to give it a valid meaning. Mm. Maintenance job start period. Okay, so now what? So now obviously it is a stored key figure because there is no calculation happening. You just saying that there was one or nothing. So stored is one. Edit allowed, obviously you want to edit it, so you'll say that this is editable in current or future, all editable. So first is not editable, that means it will not be edited. Second is that it is a system editable. What does that mean? System editable means only system can edit it. How system will edit it? If there is any calculation, system will override this value, job start period. Or if you're doing a copy operator, system will override it. Or you're running any job, that will override it. Third is editable in the current or future, so you know it. So from current period to the future periods, it would be made as editable in the past, and edit all editable. So let's make it as editable in the current or future. So now let's touch base on the planning notes concept here, guys. So let's mark this key figure enabled for planning notes, because this is a prime input which planner is giving in. So if the planner is making a decision that I will schedule this chemical cleaning in week 2, and if he is changing it, he wanted to leave a comment, a note, that why he has changed it, so that why he has taken that decision, so that that decision can be recorded. A note can be recorded inside the cloud system. So if any other maintenance planner, maintenance manager, or someone, if he's saying that why there is a change in the plan, then he can very well read the note that the planner has left. So for that, I'm saying that this is enable planning notes. Okay. And then I have to say, see, by default, when I make a key figure, from this key figure page, click on this star, give a technical ID, give a base planning level, click on OK. System by default takes the aggregation mode as sum, and then it will also list the request level calculation by default. But it is our job to go to this input key figures and say whether it's a stored value or a calculated value. It's a stored value. Saving it. Okay. Another key figure. What is the next key figure? This is one, planned capacity consumption. So here we have some calculation. What is that calculation logic? Any week, for any of this combination, if the start period is 1, pick the capacity consumption. If it isn't, don't pick anything. So let's create that. What is it? Planned capacity consumption. Z maintenance planned capa. Planning level, same planning level, week, log, resource, and job. You're saying the key figure ID is more than 26. That's fine. Planned maintenance. So now the base planning level is this. So now it is not stored now. So I want to make it as a calculator now. I clicked on calculator. Now let's write the calculation. By default, we'll have a request level calculation. That is fine. But there would be a calculation at this level, week, resource, log, resource, m job. I'm clicking on this. It says data calculation. Now I'm coming here. System by default picks up this planning level and start displaying it. So now I'm writing it. If, so what is that? The job start period, right? So double quotes, Z maintenance. Where is it? Job start period? Yes. Z maintenance job start period at the rate this combination. If this is 1, then pick what is it, that Z maintenance capacity consumed? Is that the one? Okay. If it is not 1, then 0. Now I'm validating it. Now system is saying that this has been written based on 2 key figures, and one is the capacity consumed and then start period. Both are stored. Okay. So now in the request level, I will not make it as a stored. Why? Because there is a calculation that is actually, the calculation is propagating values in it, so it is not a stored one. So now I'm saving it. Now now let's come to the standard capacity also. Let's make standard capacity Z maintenance. Next key figure is the planned capacity. We have already made it. Next is actual capacity consumed. No, I think this has to be okay. This is actual, but there has to be another key figure. That is a uh, final available capacity. That is the difference between the standard and then how much has been consumed. And now here comes a tricky one, because the planning levels are different, right? So yeah, what is the key figure name? Z maintenance final available. Okay, I did a wrong thing, guys. I mean, I haven't, you know. 1 second. It's saying that select either stored or calculated or both for this key figure. So for now, I'm just saying that this is stored, but we'll come back. There's a small thing that I haven't done it properly. That is a standard capacity. Where is the standard capacity? Yes. See, the standard capacity is not supposed to be at log resource M job. There is no such thing as a maintenance activity coming in for the standard capacity, right? So weak resource location. So there is a standard planning level called as a weak resource location. Okay. Now it is saying that the operation will change the base planning level of a key figure. All calculations associated with this key figure and dependent key figures should be adjusted accordingly. Okay, fine, I'll do that. So now I need to come here and also change this. Stored. You guys are following me, right? Because the standard capacity is at a location and resource level, so there is no maintenance thing involved in it, right? That's why I made as a weak resource location. Okay, now let's come back to this the calculation that we have. Final available capacity. What is this final available capacities? This is a difference between what is the standard capacity and how much is the planned capacity consumption. So I'll come here, I'll make it as a calculated. I'll take this off and I'm writing, and this isn't it's not a stored. Now if I write this calculation, now system would throw me an error. Let's see. So it is not if, it is just a simple subtraction between the standard capacity, that is a Z maintenance standard capacity at a weak resource location, minus it is our planned consumption Z. So it picked up two key figures. One is the Z maintenance planned capacity consumption, that is at a weak log resource M job. The another key figure is the maintenance standard capacity, that is a weak resource location. Okay. Okay. I made it another wrong. That is, the final available capacity also has to be at a week. The final available also has to be at a location and resource, right? We don't want to get into the maintenance job also for this key figure. Why? Because these values will ultimately get into another key figure, that is actual supply planning related key figure, that is a capacity supply. You remember, we have talked a lot about it. So capacity supply hard constraint, this would restrict the entire production activity for optimizer. No, so this capacity supply by standard, this is at a location and resource and a weekly level. So if you want to populate values into this key figure, and then you better do your calculation at location and resource level. So, but here, final available capacity, I gave it at a week log resource m job. Now I'm taking this off. It's a week resource location. It's saying please change everything. Okay, I'll change it. It's stored. Now I'll come here. I'll edit this. Now here in this drop down, because I'm writing a calculation for this, right? If I say this validate, now this will say this give this information. The union of attributes of all input planning levels should be equal to the attributes of the output planning level. Do you want to reset the expression? Read the error message once again, you will understand it. The union of attributes of all input planning levels should be equal to the attributes of output planning level. Now, what does that mean? So you're writing this calculation. Huh? So A is equal to B plus C. Key figure A is equal to B plus C. Okay. Key figure A, the base planning level is in, you know, let's just say that key the key figure B was at a planning level called Y, and this has a first attribute as Y1. It has a Y2 attributes are attached to this master data called Y, and the base planning level of key figure B is Y. Okay, the base planning level of C is at X, and here X is been made of X1 and X2. So now if you want to write this calculation, ouch, sorry, if you want to write this calculation, you better make the resultant key figure, that is output key figure, and the output key figure planning level has to be at X, Y. This is error that it is saying. Even if you don't maintain this, system would throw a failure message, because the union of input key figure planning levels, input key figure B has Y1 and Y2 attributes, input key figure C has X1 and X2. The union is X1, X2, Y1, Y2, but they are not matching with the key figure A. So let's read the expression again. What the hell? What happened? Okay, so it is picking up the M job planning level. Remember? So now I'm switching it to weak resource log. This is error message. The union of attributes of all input planning levels. So you can write A is equal to B plus C plus D plus E or minus F, and all those B, C, D, E, F key figures will have different planning levels, and every planning level is being made up with some attributes with master data. So now if I take the union, that should be equal to the attributes of the output planning level. Okay, that's the thing. So yeah, now how do we fix it? So how will I fix it? What should I change in this expression now? I have to focus on this. The planned consumption, that is at a detailed level. So you see, this planned consumption is at a maintenance job, location, and resource level. I have to bring it to the location and resource level. Okay, so for that, I'll do this. First, I'm deleting it so that it will stop throwing me some error messages. I can switch back into other keyword. Otherwise, it will not leave us, and it will force us to fix it. So yeah, and where is our planned consumption? Yeah, I'm coming here. Now there is this calculation that's happening. If that is a start period, then copy the capacity consumed. Now here I am aggregating it to a particular level. From the location resource M job, I am making this to week resource location only. And now here I'm saying do the sum or average, or you pick up how you want. Okay, what I've done is this planned capacity consumption. Okay, so that is at a detail level, at a maintenance job, at a location, at a resource. But I want the planned capacities. I want to use these values, the 68 and 50 on week 2 and 50 on week 1. I want to use these at a location and resource level for my other calculations. So that's why I am transforming this value and I'm taking it to another level higher and making it to an aggregated level. So that's why I have written the calculation called just doing a sum and then putting this in here. So now what happens, this planned capacity at location resource, that will become 68 plus 50. Or if I take average here, system takes the average of 68 and 50 and then stores the values at weak resource location, average of those values at weak resource location. Another thing here, if you guys have carefully observed, now we are violating this funda right here, that the union of all input key figure planning level attributes has to be equal to the output key figure planning levels. But here that is not happening. You see this, the input key figure is maintenance planned capacity consumption, but that is at a weak location resource M job, but in the output there is no M job. Then why system accepted it? System has accepted it because you're doing a simple aggregation within the key figure. From a base planning level, you are going a further step high, so then system does it automatically. It will not throw any error. Okay, so yeah, now let's come back to our final calculation. There's a maintenance no, final available. Hey, 1 second guys, just give me a break. Hey, hello guys. Sorry for that. Um, yeah, so where were we? We are writing a final calculation for this final available capacity, which is a simple subtraction between the standard capacity and the planned capacity consumption. One challenge we faced, that is this key figure is at a detail level at the location resource maintenance job, but we want to utilize those key figure values, but not at the maintenance job level, but only at location resource. So that's why we have seen the errors that we are getting, because the union is not matching. And this, trust me guys, this is error that we get it much frequently. And I have also other scenarios, tomorrow and day after tomorrow we'll try to write this kind of a complex key figure calculation logics and the errors that we get. So I transformed it at the level that I want in that key figure calculation itself, and then now I am using it here. Now calculated plus this difference between z maintenance is a standard capacity. This is planned. So see, standard capacity, weak resource location, maintenance plan consumption, weak resource location, output is at weak resource location. All cool. Validating it, and now system can read that uh, standard capacity is a stored, but whereas the planned consumption is not a stored, it's a calculated one. It's fine. Click on OK, click on save. So if you want to see how the calculation is working on to in a graphical format, in a tree diagram, in a tree structure, so there is this view here. You can toggle this up, and then so this is a calculation logic that's happening. So let me take a screenshot of it, and then first I want to schedule this for. Okay, click on F, it will toggle back to the formula view. Okay, so anything else? I think we did everything, right? So yeah, activating it. Activation started. See the log for full result. So let me go back, and then there is the log here. Keep a track on the log. So I think yeah, we covered everything. Okay, this activation is going on for test config. Okay, checking the relations. Okay, now come back to this thing here. So what is happening? So here you can see two colored boxes. One is yellow colored box, another is a blue colored box. So yellow means that there is a calculation. I mean, it's a stored value, and then blue means that it's a calculated value. So now this and this comes in technical names, guys. So we have to be we have to take some pain in understanding it. So this planned kappa consumption is taking the values from the job start period and then the maintenance capacity consumed. So remember that calculation we wrote. If this is one, pick the capacity that is the capacity that it consumes. If it is 50, populate 15 here. If it is 0, don't do anything. And for what it has to do this calculation, it has to do that calculation for this level, that is for every week, for every location, plant 1, plant 2, plant 3, etc., and for every resource, and then for every maintenance job. Okay, for all the valid combinations of this, right? So there could be 3 maintenance jobs for one plant, but only one maintenance job for another plant. So that unique combinations, for all the available combinations of this, you have to do this calculation and then put it here. And then you can see now this week lock ras m job, now that is becoming to weak resource location itself. You see, now this blue one which is calculated, further went into a level up, that is weak resource location. Now here we have another one, that is a standard capacity, which is at weak resource location, LO1, that means it's a stored value. Now take the difference and put it in the final available capacity, that is at a weak resource location, and then you can finally you have a request level that stays on the top. And yeah, so refresh. Just want to where is it? So in the disaggregation modes there are 4 modes. I think you guys are aware of it, but just want to highlight. Aggregation is fine, right? You do the summation. If you say min, it picks up the min. If you say max, it picks up the max, and average and custom. Like how to understand that. So maintenance cost is one key figure. Yesterday we have created it. So um, there is a oiling job, and there is a dry vacuum, and then there is one chemical cleaning, right? And then all are happening at one resource called as a robotic assembler. Okay, so now if I do if I put the aggregation mode as a sum, and if I view this robotic assembler maintenance cost, oh, sorry, now for summation, what it will display? It will display the sum of the detail level combinations, right? If I do a minimum inside the robotic assembler, there are 3 jobs. It will pick up the minimum value, that is, it will show you 100. If you say the aggregation mode is max, it picks up 250. And if you say it is an average, it picks up the average of. Now come to the disaggregation mode. What is disaggregation mode? I mean, you guys are aware of it. So um, if I maintain my cost at, sorry, this is not the right way to do. So if I say my costs are 300 at an aggregated level robotic assembler, and the disaggregation mode is equal distribution, then it distributes it equally. So then it becomes 100, 100, 100. Okay. And if I say copy value, it becomes 300, 300, 300, right? So in some scenarios we use the copy value, right? I mean, copy value also makes a lot of sense. uh, for example, you remember location sourcing ratios? There is this one DC connected to plant 1, and then it's connected to plant 2. You want to maintain location sourcing ratio, and then for next quarter it is just zero point 0.4 here and then 0.6 here. You cannot open every week and maintain 0.4, 0.6 for the next 3 months of your year, quarter 3. Instead, you can open it at quarterly level, the data, and then you punch in zero point 0.4 at quarterly level for this ship from plant 1, location that is DC, and you save it. System copies zero point 0.4 across all the weeks. That is when the copy disaggregation mode comes in handy. And there are other things also, like there are other disaggregation expression, etc. We'll see them. We have them in as per the course plan. So next is proportional if aggregated value is not 0, otherwise equal distribution. So what does it mean? So let's say this is week 1, this is week 2, and this week 3, I'm saying proportional equal, proportional if it is not 0. So if I say this as 0, And if I say this is 300, now system while disaggregating this robotic assembler cost across the three maintenance jobs, so system sees the detail value, this is 0, then system just leaves this up and gives equal distribution of 150 and 150 here. Or if I maintain this as 1, 2 and 3, and if I punch in 300, and system does it as per these proportions. Okay, now let's take the week 4. So proportion, this is copy. Same thing, if you say this as 0 and if you mark this as a 333, and system copies a 333 and 333 and nothing in here, because in this combination robotic assembler chemical cleaning, you already mentioned that this is a 0 in the time bucket, so then disaggregation will work in a different way. So you guys are aware of it, just but repeating. I hope it won't fail, guys. Okay, I think now it is done calling post activation activities. Now what we'll do after this, once the activation is done, first load the master data, especially for the attribute that is capacity something, right? We maintain uh, capacity consumed, so we'll give 50 hours for one maintenance job, 68 hours for another maintenance job, etc, etc, and then we'll verify the attribute as key figure, and we'll see whether how that 50 value will be spread across, and then we'll we'll reload the that we'll reload that attribute value, means we'll update that attribute value, I mean to say, and see the impact on the key figure. Okay, then comes then we'll come up with this key figure logics. Okay, first we have to uh, maintain the uh, job start period. Okay, I'll give 1, and then verify the planned consumptions. Okay, then and then also load the standard capacity, and then verify the final available capacity. Yeah, we'll do all this, and then also in maintain job start period we'll also do the planning notes. Let's do it in the end. Okay guys, so let's come here. I hope it is. Activation successful, boom. Let's come here and then log into the configuration. First thing, let's load the master data, and then also let me open the planning log. Don't have any planning log, no planning sheets. Let's bring the container planning. So I'm where is this location, resource, maintenance job? Yeah, here it is, edit mode. You see this is the available combinations that are already there. Location is mill, New York, 2 resources, manual assembler, robotic assembler, chemical cleaning job, um, mill southeast, same resource, robotic assembler, 2 activities are happening. So now here I'll say this is 50. uh, if I keep my cursor here, it is saying that this is 18 digit decimal number with 6 decimal places, 50 and and manual it is 50. So robotic I'll just set to 10 because robotic always efficient, it will take less time. Chemical cleaning robotic assembler 20, and the dry vacuum service is 100. Let's just say I'm saving it. Sorry, at the first part I loaded the master data, means I updated the master data with for that particular attribute itself. So now let's come here and let's open that key figure. What is that? um, Capacity, nope. Capacity required by the job. Okay, so let's take this off. Let's bring the location here. Don't need a product ID, but we need location ID. And if you, I mean, you guys have observed that the 50 values is has propagated across. So usually the attribute as key figures when you're bringing unit prices. Today the interface has run. It bought the $20 from the material master. The $20 would be copied from the current bucket to the entire horizon. So now I'll open this back, and then uh, for this I'll say this is 55. Then I'll save it. If I do a refresh, now it becomes 55. Okay, so tomorrow if I do this 55 again, if I change it to 66, week 19 would be preserved, right? Because tomorrow if I change it, it will take from period. You remember in the planning area we mentioned from and to periods, so that is coming in play here, that is coming in handy here. So from is 0 you mentioned. So tomorrow if I update it 66, so week 19 would be preserved. From week 20 it is 66, and it is spread across 66, 66. Okay, so now let's bring the other planning. So but before that, let's maintain the standard capacity also, shall we? The standard capacity. Okay, so let's pick our stuff. Mm, 3 unique combinations. Standard capacity. So I'll say this is 168 hours, 168 hours, 168 hours. Okay, so let's come back here. First bring our that start period. My, what is it, start period? Yeah, maintenance job start period. Great. And then next one is planned maintenance capacity consumption. Great. Now come here, go into the other tab, guys. Location resource. um, standard capacity, planned kappa consumption, final available capacity. Okay, just give changing the names so that we can reuse this template. Capacity planning, then this is maintenance planning. Okay, there are other unnecessary resources coming in here. Let's put a filter. Why we need product ID here? Resource ID, and yes, these are the three resources that we are currently planning in. Okay, and why customer ID is coming in? Yeah, delete selected attribute. Okay, and why the standard capacity is not coming in? We changed it, right? Is it because of the conversion factors? So you see, here you're saying that this is target unit of measure is EA, so that's why it is coming in like this. So yeah, first let's do this here. Start period is 1. As a planner, I went and then I said that this is a start period. Just gave a flag of 1. So I mean, it's up to the planner whatever he wants to give. And then if he wants to give some a particular value, and then we need to write the key figure calculation accordingly, right? Because in the if clause we mentioned it as 1. So you can see here planned maintenance, this is 55 is coming in, planned capacity consumption, this is 10 is coming in. Let's go to this tab and then let me bring up the values in here, the final capacity stuff. Because there the settings are kind of a different location. Standard capacity, planned. Okay, see target unit of measure, it is blank, it should be blank because these key figures we haven't configured any unit of measure conversions, so that's why this is popping up. That is restricting the values to get displayed. So I created I mean just bringing that stuff into key figure. Okay, so you can see the values here. It's kind of cluttered, I know, so let me shift this location ID to further, so now it will make more sense to us. So here plant consumption is 55, and then here this is consumption is 10. So final available capacity, the difference is happening here, and then we have seen the final available capacities across these resources. So here in week 19, I said this manual assembler, this chemical cleaning, it is 55. That 55 is appearing here, and it is doing a subtraction with the standard capacity. Now I have available capacity as 113 here. Okay, so I think yeah, let's do this here. So here this is 1, right, and also here I'll maintain it as 1. I think this would give us the right results. Right results means because one resource we have 2 jobs, so So now in here, what happened on the week 20, on the same resource robotic assembler, I'm doing both chemical cleaning and dry vacuum service. So chemical cleaning has consumed 20, dry vacuum has consumed 100. So now total consumption is 120. Available is 168. The resultant available would be 48. So now if I go here, see now the final available became 48 here. Now let's create another alert key figure, tomorrow. And then we'll maintain some thresholds. So we'll say that if available capacities are less than this, I want an alert. I'm talking about Excel alerts, a key figure alert. Remember, if it is a key figure alert, anyone who can access that planning area can view that key figure, because it's a key figure, it's a planning area element. But whereas a web UI on initial days we have seen, that is like end user specific, only he can make it and he can view it. But like we are introducing a configurable key figure in here. So now let's see here, the available capacity has dropped a lot, it became 48. Now as a planner, I want to just move this to another period. So now I'll change this. Okay, and then I'm clicking on note here, right click, add planning note. Now I'm giving a note, shifting the uh, maintenance activity to, let's say, week 23. Okay, just leaving a comment here, note, and then I'm making this one here. Again, I leave another note, add planning note, updated maintenance schedule. Come and give save data here. So now it will give me two messages here. First is how many cells have changed? Two. How many planning notes have changed? Two. I left two notes. I'm saving it. So now, this is visible across the planning area, because the note is saved in the cloud. So anyone who's opening the same sheet, for example, maintenance manager or any other planner is opening it, he'll see a note here, and then he can right click, and then he'll say show planning notes. Now it will give a detailed thing. So first, this icon is a stored, that means the note is been stored. He has left the note, he stored it, the note is saved in the database HANA cloud system. What is the note? Shifting the maintenance activity, capacity is way low, cross checked with the team on the same. So the value is 0. I mean, that is a value that has been there, changed on this particular time, and changed by edit, delete, for what planning combination. This is a beauty here. So you can see here for what combination he has actually changed this value. Okay, so now I'll go and say one again here, and I'll say here, and I'll leave another note. Re-updating the maintenance activity. Team is fine with lowest capacities, high priority, um, high priority maintenance activity, something like that. Now I'll save it now. Then so again the calculation will work. If I do a right click, now I can see two notes being left. So what is a value that has been updated? One. So there is a new note, and you can see that they'll get sorted as per the timestamps, and then now I can go and delete this and etc. So if a third person is coming in, and if he is typing another note, so this would keep on building up. So and same here, show planning note. Okay, and then So for example, let me take off this maintenance job. So I'm not sure what is the disaggregation mode that I maintained. It is proportional. Should I maintain copy? So what I'm trying to show you guys is that I opened it at an aggregated level. So I'll go to the future horizon. Let's say on week 33 of 2019, I'm giving 1. At what level? At a resource level. So that means there are how many jobs inside it? 2 jobs, chemical cleaning, oil cleaning. So now I'm at an aggregated, I'm giving 1. Now I think as the disaggregation mode is proportion, so it takes zero point 0.5 and zero point 0.5. No, one second. So but what I'm trying to show here is that I'll give a note here. Just observe it clearly that I'm leaving a note at an aggregated level. Okay, adding note. um, Forecasted maintenance activity. So, I mean, I can change it to 10. I mean, I can leave a note at any level. I mean, not any level. I mean to say that um, mm, I mean, once the value is updated, then also I can go and leave a note. It's not a mandatory that, while you're updating only, you have to give a note. So even on a static value also, you can go and give a note. So that's fine. But only thing is that you have to configure the key figure for the planning note. So now if I go here, if I open it, where is our week? So this is coming in here. So you see the note has been there. Now if you see here, forecast maintenance activity, the value is 1, changed by this guy timestamp. Now the level is that mill location ID and resource is robotic assembler, but he hasn't left a note at a detail level, that is at a maintenance job level, but he has maintained the note at an aggregated level. System also disaggregates the note to the detail level. So that's the thing with the planning note. So if the planner wants to leave a note, he can leave it at any level he wants, and then system would do a disaggregation accordingly. So that's it, guys. That's it for today. uh, so we have seen so what we have seen is a small recap. um, Attribute as a key figure. The what are the major things that we did in the attribute as key figure? First, create a new attribute and make sure that this is decimal, and add this attribute to the master data. Activate the master data, extend this attribute to the planning area, and there checkbox the key figure. The moment you do this, system will ask what is a planning level. Keep your planning level handy so that the static value that you maintain, our example, we maintained a static value of 55 that has propagated across the horizon, and then the planning level you have to be in handy. And then what we have to do, another thing, maintain the request level calculation. Remember, we did a request level calculation. Otherwise, system during the activation it will fail, saying that it is mandatory to have a request level calculation for any key figure. So now you made the attribute as a key figure. Now please go and write the request level calculation also. So by default, it is always the sum. Aggregation mode is sum, but you can maintain it as average or min or max, etc. And you also can change the names of the these things. So that's it. After this, you have load the usual planning model cycle. Remember, so we just done with the define part, and then we activated the planning. We activate the planning area, and then we load the master data attributes, and you can verify the same attribute value across the time horizon, and the time horizon has to be in here. And now you also give a from and a to period. Okay, this is about the attribute as key figure. Next is we did a calculations. We created couple of key figures. We have seen the how we have to write a key calculation logics, especially when writing a calculation like c is equal to a plus b, key figure c is equal to a plus b, how the planning levels comes in picture here, and how they'll conflict with each other if the union thing is not working. And then we did simple calculations like subtractions and etc etc. So yeah, that's it, guys. So about the tomorrow session, I'm not sure we are planning to have a session or not, because tomorrow being a weekend. So I'll check with the team. I think the team will give you an update whether we're continuing with the this thing or not. So next plan would be we'll continue with the other things here in the key figures itself. So there is this snapshot key figure. We'll make a snapshot key figure. We'll make an alert key figure, and then we'll also do enable fixing and how to fix some things, and we'll do some convert using is like unit of measure conversion. You can view a key figure at eaches or cases or pallets or etc. Or if it is revenue related key figure, you can view it at the USD, American dollar, or Indian rupee, or etc. And you can do both quantity and the unit of measure conversion. So we'll see that, and we'll try to come up with other complex key figure, calculations, and then at different levels, and how we can resolve it. Okay, guys. Any doubts? Okay, then we'll touch base maybe tomorrow or maybe on Monday. Again, Monday also, Indian time, Monday morning. We'll have a session or not. Again, please leave a comment to the meeting coordinator, and accordingly we can schedule and you will receive an update on it. Okay. Thanks, guys.
Sure. Thanks.
Have a nice weekend. Bye.
Thanks for that.